In this video, we're going to see how Docker containers can be used to run advanced networking tools within a Phoenix Contact PLC Next controller. Now, why might you want to do this, you ask? Well, PLCs, even smart PLCs, are typically fairly limited in resources. This keeps the attack surface down and the likelihood of encountering software issues low. Docker containers are an outstanding way to run programs ephemerally to keep those resources free. Let's say you have a networking issue you need to troubleshoot, and you want to use a packet capture utility such as T-Shark, the CLI equivalent of Wireshark. Let's take a look at how to quickly and efficiently run this tool in a container and avoid having to install it fully on the system. We're going to encounter a few issues along the way to help you troubleshoot these messages in the future when deploying other tools. So, let's get started. First of all, make sure you have Balena Engine or Docker installed. Now, I have set up an alias to configure Balena Engine to the Docker command. That way, I can copy and paste commands and use Docker like I'm used to, even though I'm actually using Balena Engine under the hood. If you have questions about this, you can of course check out my other videos, which include that process. Now I'm just going to check Docker ps-a, everything is working, Docker is installed, so that's great. So what we're going to do is we're going to use the network multi-tool container, which includes a lot of great networking tools. Now we're just going to use T-Shark in this video, but feel free to peruse that and find other useful tools. Here it is here. And if you scroll down, you can see this is the default image, but if we scroll further, you'll actually see there are several variants. So here is the minimal variant, and as you can see, there is no T-Shark. If I scroll down to Alpine Extra and Extra, you can see T-Shark is here. Now, Alpine is just a somewhat smaller container, so in our case, since we're running on a PLC, the smaller the container, the better. So what we're going to do is we're going to run that container. Now, you can see a few instances down here, but none of these are exactly what we're going to use. However, some of the instructions can give you some hints, such as, to run this, we're going to need to specify environment variables for the HTTP port and HTTPS port. This container runs Nginx by default. We don't need that in this video, so that's not a big deal, but the container will fail since the PLC is running something on HTTP and HTTPS. So we want to make sure this container doesn't fail, so we'll need to provide these environment variables. Now, if we take a look in the Docker run instructions here, you can see there are a lot of options. If you're not familiar with Docker Run, we will try to go through these as carefully as possible, but as quickly as possible. So let's go ahead and run this container multi-tool, and then we'll start to see what type of errors we hit and figure out how to most efficiently do some network troubleshooting. So what I'm going to do is run Docker Run, and then let's add those environment variables, just like so, just like that. So now that we've done that, the next thing we want to do is use the RM flag. So if I take a look here, what this is going to do is it's going to automatically remove the container whenever it exits. If we don't run this, every time we run our container, it's going to leave a dead container behind, and that's going to get pretty messy as we go through this lesson. So we'll add that --rm, and then what I'm going to use is -it. That's actually the combination of two different options. That's interactive, right here, -i, and this will keep the standard input open so that we can interact with the container. And we're going to use the -t, which is right here, which gives us a sudo tty, which is how we're going to be able to type commands and see what comes out of that container. So we've got those two. Let's now specify the container itself. And again, we're going to need to specify the Alpine Extra version of this container. So we'll type wbitt/network multi-tool, and then we're going to add a colon, Alpine Extra. So now that we've done that, we have one more thing we need to add, and that's a process to run whenever we start this container. Since we're running it interactively, we have to run a process. That process is going to be bin/bash, and hit enter. All right, it's pulling down the image, which will then be executed. All right, great. We are now in our console for that container. But let's take a look. Let's see if this thing is ready. First thing I want to do is find out the interface on which we want to capture. If you look at the T-Shark man page, you can see the first thing we need to do is specify the capture interface. So if I run an ifconfig, you'll see we have an address that is not actually the address used by the PLC. I'm logged into the PLC here. As you can see, I'm in 192.168.1.10. So we're using the Docker network. So this is the first issue we've encountered. I'm going to exit out of this container. And if I run a Docker PS, you can see that container is no longer there. Once that process cancels, the container exits. So the next thing I want to do is add the network flag. So I'll just press up a few times, and I'm just going to scroll back here. I'm going to add it to the beginning, network host. This is going to give us access to the host network. So if I hit enter again and get into the container, I can then type ifconfig, and now we have access to our interface, LAN 1. Fantastic. So now I can run tshark-i LAN 1, and now we've hit our next issue, operation not permitted. So what we're going to want to do is give some capabilities that will give it access to our networking stack. If I take a look at the capabilities man page, I can do a Control F for network. And as you can see, we have capnet admin and capnet raw. These two are what we're going to need to ensure that we have access to everything we need. This will give us access to our raw and packet sockets and give us access to everything else we need to capture the packets coming over that interface. So to do that, we're going to use the cap add flag. And of course, all of this can be found here in this Docker run documentation, add Linux capabilities. So let's press up again. Let's go ahead and add those capabilities. I'll head right here. We're going to add cap add and an equal sign, net_raw, and then another cap add equals net_admin. Just like so, and hit enter. All right, as you notice, there are a few things here that you may see which you can just safely ignore. Don't worry about those little errors, but of course you can read the documentation to get rid of them if you'd like. Going to click clear. Now, tshark-i LAN 1. And we are capturing packets. Beautiful. So let's try something a little more deliberate. Going to run tshark-i LAN 1-f, and let's look for ICMP packets. I'll head over to another terminal and just ping 192.168.1.10. And there they are. All right, perfect. So this is working exactly like we had hoped. Once that's done, I can hit Control C to stop the listening and stop that. So now let's see how to make this a little bit easier for us to use without having to run that long drawn out command every single time. First thing I'm going to do is figure out exactly how I want to save these logs. So I'm going to make directory var log dumps. And then let's run that command again and save it to a file. We're just going to add the -w, var log dumps, dump.pcap, and run this command again. As you can see, we are capturing some packets there. Once that stops, I'll hit Control C. And if I cat var log dumps dump.pcap, you can see we have a binary file here that only tshark wants to read. So to read that, we can run tshark-r var log dumps dump.pcap. Perfect. And then we've just got to find a way to not have to log into this bash command line every time we want to run tshark. So I'm going to exit now, and let's get started on that. First things first, we're going to make a new directory, var log dumps, on the main system. That way we have a place to store those dump files for whenever the container exits. Otherwise, those files are deleted every time the container exits. Now what I want to do is mount this directory to our container so the container has access to it. I'll just scroll back a little bit. You don't necessarily have to do them in this exact order, but it's easier for me to read. So what I'm going to do is use the docker mount command. You can also use the volume command, but mount is actually preferred now. So we'll use mount type equals bind source equals var log dumps, and destination equals var log dumps, just to keep things easy. Once I hit enter now, oops, So that's one thing you'll see. Need to make sure we add that slash here. And enter now. And we're back in. So if I run tshark-i lan1-f icmp, run that ping again. All right, that's working. I'm then going to add that -w var log dumps dump.pcap and hit enter. And run this again. All right, perfect. Now I can check the container to make sure it's here. tshark-r var log dumps dump.pcap. It's there. When I exit the container, we can take a look. Cat var log dumps dump.pcap. And there it is. So it's available on our external system outside of the container. So we have that dump backed up. So now let's go ahead and see how to create just a tshark command that will run all of this for us. So what I'm going to do is just scroll back up to our main command here. Going to remove the bin bash, and we're actually going to run tshark. And then I'm just going to scroll all the way to the beginning, or you can just use the home key if you have that. And let's just create an alias, tshark equals, and wrap everything in quotes. I'm sorry, I did not say that in the beginning. Hit enter there. Now, tshark-r var log dumps dump.pcap. As you can see, it runs a container. We can see those original errors that we received, and it read our dump file. So now I can run tshark-i lan1-f icmp. Those quotes are not actually required unless you're adding multiple items to that. And -w var log dumps dump2.pcap. And again, this is running inside the container. Keep that in mind. All right. And we will run that ping one more time. As you can see, we're capturing those packets. Control-C that. And then we can do that read one more time. Dump2.pcap. And congratulations, you now have tshark running within a container and not being stored on the PLC itself. Every time you run it, it is subsequently removed, keeping your PLC nice and clean without network sniffing tools lying around. So let's go ahead and remove that image if you are finished, of course. Docker RMI-F, Docker images-Q, and that removes every image on the system. Please do not run that if you have other important images, but for us, that's perfect. All right, so that is everything for this video. I hope you enjoyed it. Please feel free to sound off in the comments for any other interesting ideas and tools you've thought of, and thanks for watching.